Hello, welcome back to the AVCOM lecture series of the GTU. Myself is Dr. N.K. Chavda, working as an Associate Professor in Mechanical Engineering Department at A.D. Patel Institute of Technology, Vallabh, Vidyangar. I am going to deliver a talk on the properties of steam, chapter number 4 for the elements of mechanical engineering. The content which I am going to deliver are difference between gas and vapor, formation of steam, types of steam, specific enthalpy and specific volume of steam, and numerical based on types of steam, specific enthalpy and specific volume of steam. And if time permits, we will continue with the density, external work done and internal energy of steam, and numerical based on steam. As we have studied in the primary standard, there are three states of a substance: solid, liquid and gas. So we know that gas is a substance in which there is no liquid particles, and vapor is a partly evaporated liquid which contains mixture of liquid and evaporated liquid. It means vapor has a two-phase, example of a two-phase. It has the liquid as well as the partly evaporated liquid. Gas, examples of the gas are the oxygen and nitrogen, while examples of the vapors are steam, which is a mixture of water and water vapor. Now, before we study the complete chapter of properties of steam, we must know what is the application of steam, why we have to study the steam, and where exactly the steams are being utilized. So, the application of steams are to run the steam engine in a locomotive train, to run the steam turbine in thermal power plant for generation of electricity, to transfer the heat in industrial processes and in steam sterilization process. It means steam is widely utilized in electricity, in trains, in industrial processes and in sterilization process. It means steam is required everywhere, and so we have to study the formation of steam and the properties of steam. Formation of steam, how we can generate the steam. So, for a layman, if I want to generate a steam, I have a simple homemade example. Take a vessel, fill it with the water and put it on the gas. So, what will happen when we switch on the gas? Water will start heating and it will generate the steam. So, we can see the steam is generated. But when we are studying in an engineering subject, the steam formation is a very important one, where we have to find out, or we have to see what are the different stages of the steam generation and what are the volume, specific volume and heat energy related with the steam. So, assumptions in the steam formation, first one is consider a frictionless piston and cylinder assembly. It means we consider a frictionless piston and cylinder assembly, there is no friction, and we are filling it with the 1 kilogram of water inside the piston and cylinder assembly, which is at 0 degree centigrade. It means we are going to generate the steam from the water at 0 degree centigrade temperature. Third assumption is area of piston is 1 meter square, means we have considered that area of piston is 1 meter square. Fixed weight W is kept on the piston. So, we are putting the fixed weight W on the piston, and due to the weight on the piston, some pressure will be acting on the water, and as the weight W is fixed, the constant pressure is acting on the water, and that is equals to P is equals to W divided by area of piston, and volume of water is VW. Now, what is the meaning of pressure and why we require the pressure, and what is the effect of pressure on boiling point temperature of water? Generally, if anybody asks a question, what is the boiling point temperature of water, generally we answer that boiling point temperature of water is 100 degree centigrade. But this is not actually the correct, or you can say partially correct answer. Technically, we have to speak like that: boiling point temperature of water is 100 degree centigrade at 1 atmospheric pressure. It means if the pressure on the water is 1 atmosphere, then the boiling point temperature will be 100 degree centigrade. And in a technical term, boiling point temperature is known as, or it is termed as, a saturation temperature, and it is denoted by the symbol T sat. So now onwards, technically we have to speak boiling point temperature as a T sat. So what is the boiling point temperature at 1 atmospheric pressure? So 1 atmospheric pressure boiling point of temperature is, boiling point of temperature of water is 100 degree centigrade. Now when the pressure of water will decrease, what will be the effect on boiling point, or what will be the effect on the saturation temperature? So when the pressure on the water decreases, the boiling point temperature, or you can say the saturation temperature of water, decreases. So as seen in the, so as the pressure has reduced, the saturation temperature of water has reduced, and if the pressure on the water increases, the saturation temperature increases. It means for the generation of steam, we have to maintain the pressure on the water constant, so that we can find out, or we can say that this is the boiling point and this much heat we have to required to convert the water into the steam. Now we will go for the Cognifront video for the formation of steam, which will give us the answer.
And study the different diagrams of phase transformation of a pure substance. Pure substance is defined as a substance that contains constant chemical composition throughout its mass. It is homogeneous in nature and exists in one or more phases. Water, air, nitrogen are some examples of pure substances. Phase. The phase of a substance is that state of the substance which has distinct molecular structure. Different phases of substance have different molecular structures. Let's see how. Solid phase. In this phase, molecules in a substance are tightly packed and have fixed position in the molecular structure. Liquid phase. In liquid phase, the intermolecular spacing is slightly greater than in solid phase. Here, the molecules do not have a fixed position. Gaseous phase. In this phase, the intermolecular spacing is very high. The gas molecules move randomly and collide with other molecules. Hence, these molecules do not have a fixed position in the molecular structure. Let us study the phase transformation of a pure substance. Let us take the example of water. Consider 1 kg of ice at a temperature of minus 10 degrees Celsius at 1 atmospheric pressure. Place this ice in a weightless piston cylinder. Let us heat this ice at constant atmospheric pressure at different instances and observe the change in phases of water. Along with this, we will also plot each phase change on a PV diagram. Observe that initially water is in the solid state. Due to heating, the temperature of ice starts increasing from minus 10 degrees Celsius to 0 degrees Celsius. Note that 0 degrees Celsius is the melting point of ice. This phase is represented by the region between state 1 and 2. As the temperature starts increasing from 0 degrees Celsius, ice starts melting. Here we observe a mixed phase of solid and liquid. The region between states 2 and 3 represents this mixed phase. On further heating, water enters the liquid phase. Water remains in this phase until the temperature reaches the boiling point of water, that is 100 degrees Celsius. This temperature is also known as the temperature of vaporization. This phase is shown by the region between states 3 and 4. On further heating, water enters the mixed phase, that is liquid and vapor phase. Note that boiling of water starts from state 4 and ends at state 5. Beyond state 5, the dry saturated steam is superheated. Hence, it is called as superheated steam. This is represented by states 5 and 6. Observe the line passing through the saturated solid state 2. This line is known as saturated solid line. The line passing through states 3 and 4 is known as the saturated liquid line. Line passing through the vapor state 5 is known as saturated vapor line. Now observe that the saturated liquid line and saturated vapor line incline towards each other and form a junction point. This junction point is known as critical point. Note that the line at which all the three phases, that is solid, liquid and vapor exist, is known as triple point line. If the substance is heated at a lower pressure than triple point line, then the substance does not enter into the liquid phase. Hence, the region below triple point line represents the mixed region of solid and vapor. Let us plot the above phase transformations on PT coordinates. As you can see, the region between states 1 and 2 is solid region and has lower temperature and higher pressure. The region between states 3 and 4 is liquid region having high pressure and temperature, whereas the region between states 5 and 6 is a vapor region having lower pressure and higher temperature. Observe that the curve passing through state 2 and 3 is known as fusion curve. The two phases are in equilibrium at all points on this curve. The curve passing through 4 and 5 is called as vaporization curve. The two phases are in equilibrium at all points on this curve. Observe that vaporization is considered at different temperatures and pressures. We know that if the substance in solid phase is heated at lower pressures, then it directly enters into the vapor phase. The curve between solid and vapor phase is known as sublimation curve. Observe the point at which all the phases meet each other. This point is known as triple point, where all the phases are in equilibrium. Note that the point at which the distinction between liquid and gas disappears is known as critical point. So friends, in this session we studied pure substance and phase transformation process. We also observed the PV and PT diagrams for a pure substance.
So in this video we have seen that steam is generated from the ice, it is at minus 10 degree centigrade. Now we are going to study the generation of steam from 0 degree centigrade water to the superheated steam. Let us see the stages of the formation of steam. Consider the as we have studied the frictionless piston and cylinder assembly having the water at 0 degree centigrade temperature, and we termed it as a state A. Now if we want to generate the steam, we have to heat it. So when we supply the heat, the temperature of water increases slowly and reaches to the boiling point temperature or the saturation temperature. So at point B or a state B, we get the water at the 100 degree centigrade temperature, and this steam or this type of steam is known as the saturated liquid. So as it has the obtained the saturation temperature, so it is known as the saturated liquid. But yet the formation of steam has not started, yet only the temperature of water has increased from 0 degree centigrade to the 100 degree centigrade. When we heat it again, the temperature water starts converting into the steam and reaches to the state C. So in the state C, we can see that some of the water is converted into steam and some of the water is in the liquid condition, but yet the temperature of mixture of water and steam is same, that is the 100 degree centigrade temperature, that is the boiling point temperature, and that is known as the wet steam. It means from the saturated liquid, when we supply the heat, we get the mixture of water and steam, and which is known as the wet steam. We want to generate the steam again, 100% steam, so we have to heat it again. So when we start heating it again, the total water, 100% of water is converted into the steam, and the temperature of the steam remains same, that is 100 degree centigrade. So you can see or you can observe that during the state B, state C and state D, the temperature of remains same, that is the boiling point temperature or it is the saturation temperature, and this happens because it is a phase transform